This brings us now to symmetry. Symmetry of a function is asking whether it can be reflected or rotated. So a function is said to have even symmetry if the function can be reflected over the y-axis. Okay, if there is a mirror on the y-axis and the function can reflect back onto itself, it is said to have even symmetry. Even symmetry is a reflection across the y-axis. Odd symmetry, so a function is said to have odd symmetry if it can rotate around the origin. So if I take this and I rotate it, it looks exactly the same again. Okay, so if I were to actually turn that graph upside down, it would look no different than it did originally. Odd symmetry is a rotation around the origin. Even symmetry is a reflection across the y-axis. Okay, the x-axis can have symmetry also, but then that's not a function because it would have repeated y values and we can't have those. Okay, so again, another examples. Line of reflection, even symmetry. Pardon the sketches. If I rotate the graph around the origin, it maps back onto itself, so this one has odd symmetry. This one looks like it would like to have even symmetry, but because the reflection line or the rotation line, the rotation point is over here, right, I can rotate this around the point and it maps back onto itself, but that's not the origin. This one looks like it might have a reflection line, another rotation. I apologize, another rotation. So it looks like that rotation point is somewhere, I don't know, somewhere over here maybe. It's hard to tell exactly where it is. So again, because it's not the origin, it wouldn't have symmetry. Again, even is a reflection across the y-axis. Odd is a rotation specifically around the origin, not some other point. So the hard part about the symmetry was the algebra. Okay, and that's what we talked about more in class today, and there are several places for you to practice. Algebraic symmetry is the more difficult one to check, okay, because it requires you to actually do the algebra. It requires you to be able to distribute and factor and things like that. By definition, changing the x to a negative x is a reflection across the y-axis. If I change the x to a negative x without changing the behavior of the function, that's a reflection across the y-axis, which is even. Changing the x to a negative x moves it from the first quadrant into the third quadrant, okay, or takes that x and makes it the opposite, where the y values are also negative. That's a rotation around the origin. Replacing x with negative x simply rotates that function to make the y's also negative. So here's what has to happen. You're going to take out every x and replace it with a negative x. We're going to take out every x and we're going to replace it with a negative x. So negative, negative makes that a positive. Those two functions are not the same. That is not the same as that. Therefore, it's not even. If it changes, it's not even. These two have to be the same. This one changed. If I take out the x and I replace it with a negative x, I apologize. If I take this one, I did it the opposite direction. It doesn't really matter. So if I make the whole function negative, that's going to become a negative 5. That's going to become a plus 3x, which is again not the same as when I replace the x with a negative x. Okay, if I replace the x with a negative x, this is what I get here. If I make the whole function negative, this is what I get here. And since this is different than the original, it's not even. Since this is different than the negative, it's not odd. So let's look at another one. I'm going to take out the x and I'm going to replace it with a negative x. Take out x, replace it with a negative x. So this becomes negative 3x. Negative x cubed is negative 4x cubed, right? And since that's not the same, it's not even. But now, again, this is what I got when I substituted x with negative x. It's not the same as the original, so it's not even. If I take the negative across the whole function, so it becomes a negative 3x and a negative 4x cubed, I get the exact same thing as when I replace the x with a negative x. So this one is odd. Replacing the x with a negative x changed the function, but making the whole function negative matched. One more. Take out the x, replace it with negative x. Take out x, replace it with negative x. Even powers keep everything positive. So that's exactly the same as it was when I started. Negative x to the fourth power is x to the fourth power. Raising a value to an even power makes everything positive. So that's x to the fourth, x squared, nothing changed. That's an even function. Now I'm going to take that negative and I'm going to distribute it all the way through the function. That becomes negative x to the fourth plus x squared plus 1. Negative x to the fourth plus x squared plus 1, which is not the same as the original function. And because it's not the same as the original function, it's not odd. This is even. It's not odd.